In this video, we are going to review setting up integrals over type 1, type 2 regions and also integrating. So this is double integrals. First, let's go ahead and review type 1 integration. Region of type 1, this is where we integrate y inside and x outside. In order to find the x limits, we look at extreme values of x. So we can see that x changes from 0 to 3. These are always numbers. The inside limits are not going to be necessarily numbers because this is not a rectangle. So we must have some variable somewhere here. And which variable? Always the outside variable. So we're looking for some variable x in the limits. And without the graph, it's hard to see which function is the bottom, which function is the top, but you can actually plug in something like x equals 1, for example, something in between, and you can see that 3x will be larger at 1 than x squared, because it would be 3 versus 1. So um, even without the graph, you can see that x squared is going to be on the bottom, and 3x is going to be on the top. So it's always bottom curve. So here we have the bottom curve, which is going to be our parabola, and then the top curve, which is the line, right? 3x. Okay, and so that's the setup here. So that let's just go ahead and do that. And it looks like they want you to find the area of the region. So double integrals, when you do an area, the interpretation of double integrals is that you're just going to be integrating one. Okay, and that'll give you the area of the region. So this goes from 0 to 3. And then this goes from x squared, which was on the bottom, to 3x, which was on the top. Okay, now evaluating the integral, we're going to do that. That's very, very simple. So this is just going to be regular integration. This is not a splittable integral. So we just integrate with respect to y, and the integrating 1 is just going to be y. And we substitute y equals x squared, y equals 3x. So substituting 3x first, we get 3x, subtract x squared, and integrating that with respect to x becomes 3x squared divided by 2 minus x cubed divided by 3. I substitute 0, 3. This will become 27 halves minus 3 cubed is also 27 thirds. So that will be 27 over 6. You can check that on a calculator if you do not believe me. Okay, now setting this up as a type 2, what is that going to be? So if you want to set this up as a type 2 integral, this is where the x is inside and y is outside. And of course, you will still be integrating 1. First of all, the limits are going to be extreme values of y, not extreme values of x. So be very careful. These are your extreme values of y here. So this is going to be 0 to 9. Okay, then it's going to be whatever is your left curve, which is this left curve is here, to the right curve. So left to right. Well, left curve was the line. What was the equation of the line? Well, the equation of the line was y equals 3x, right? But remember that the inside limits should always have the outside variables in them, right? So when you have y equals 3x, you should solve that for x. That gives you y divided by 3. That should be your left curve, right? So we can see that on the graph, that's y over 3. Now, the right curve is the parabola. The parabola was y equals x squared. Solving that for x and noting that x is positive, so we don't have to worry about the plus minus business, right? And theoretically, it's like going to be plus minus. But oops, this is going to be square root of y, right? X equals square root of y. Okay. And so that's going to be over here on the top. That's going to be the right curve. All right. So that goes here. So this would be 0 to 9. And then we had y over 3 on the bottom, square root of y on the top.